Right, so hello again to everybody and welcome to Keeping It Civil with me, Engineer Mark Salvador. Tonight, I will be presenting a short episode dealing with mixture problems, just to get the feel of how things would be flowing with multiple problems in one sitting. So, without further ado, let's continue. All right, so item number one. How many gallons of a 30% acid solution must be added to an unknown quantity of 70% acid solution to make 50 gallons of a 40% acid solution? And the choices are given right here. For a mixture problem, it is better to approach it by making a drawing of the said mixtures, the given mixtures. So for this problem, we have the following. For the solution one, we have 30% acid solution. So we're going to put it in a box like this or any vessel shape that you want. And here we have the details, solution one. We have its percentage and we will name it as X gallon. And according to the problem, we have to add another one. So we have to add the next one, which is solution two, 70% acid solution. And we will name this the Y gallon. Of course, you can't name it the same variable because these are two different liquids with different concentrations, right? And finally, we have both of them are equal to the final solution, which is solution 3, a 40% acid solution, which is 50 gallons in total. Let's proceed. All right, so once we set up this problems drawing like this, or visualization rather, we can proceed with the equations. Now for mixture problems, usually there are two equations to begin with. So the first equation is as follows: the x plus y is equal to 50. Now, where did this come from? This one came from focusing only on the volume of liquid inside. So we have x gallon, y gallon, and 50 gallons. Disregard first the percentages on top and the name of the solution. We're setting up the first equation here. So the first equation is here. Simple algebra, we'll call it a equation 1. Simple algebra, and since we are solving for x for 30%, I would rather solve it in terms of y because that way at the end I get x. All right. So let's mark that. Let's underline that. That will be our y. The next equation is as shown. Now let me explain. For this first side, 30% times x, what I did now is I combined the percentage solution with the volume. Of course, you multiply it. So 30% of x gallon plus, the next one is the same, 70% acid solution times y gallon, and equal to 40% of the 50 gallons. If we continue, I will first convert the percentages into decimal points. We'll call it equation 2. Once we convert it to decimal points, it will look something like this. All right. So simple algebra. What we can do here is the y here, we will substitute this equation right here so that we get one unknown and one equation that which we are focusing here. And like I said a while ago, since we are solving for the x gallon, I made it in terms of y so that at the end we get x gallon for the 30% solution. Now with this equation, I'll bring out the calculator again and enter it. So 0.3 times x plus. Now be careful when entering parentheses in your calculator. Make sure that the number of parentheses when it's inside of another set is correct. Otherwise, you'll end up repeating entering the equation again. Shift solve and we get 37.5. 37.5 gallons for the X gallon, which is the 30% solution. Going back to the choices, there it is, letter B. That's the answer for item number 1. All right, let's move to the next item. Item number 2. It says here that you need 10 liters of 15% chemical X solution. Available to you are 10% of chemical A and 30% of chemical B. How many liters of chemical A and B do you need to make the desired solution? Well, for this one, we're going to be solving for both volumes. All right, that's no problem. Let's start to visualize it again. So for the first vessel, I have chemical A, which is 10%, and I named it X liters because liters is what they're looking for. Then we add the next one, chemical B, which is 30%. And finally, we have chemical X, the final solution, which is 10 liters total and 15% in concentration. All right. Next step. We're just going to be doing the same step as item number 1 here. So X plus Y, which is the volume, and we'll call it equation 1 again. So I'll start by solving in terms of Y so that I can get the first vessel's volume. All right, so we'll keep that there. Next, same as item number 1, we have the 10% times the total volume of the first vessel, plus 30% of the total volume of the second vessel, and finally 15% of 10 liters, which is the final vessel's volume and concentration. We'll call this equation 2. All right. So I just transformed the percentages into decimal points and simple algebra once again, and substituting y here to y in this equation, number 2, and we get the whole equation as is. All right, I'll bring up my calculator again and enter it. All right, 0.1 times x plus 0.3. Keeping track of my parentheses so that I won't have a error. 1.5. Shift solved. We get 7.5 liters for X, which is chemical A. All right, this is just the first chemical, chemical A. Remember, we're looking for 2 chemicals. So for chemical B, all I have to do is substitute the value of X here to the first equation. Since we are focused on the volume, we will get this equation continued. And the final answer for Y is 2.5 liters of chemical B. Looking back at our choices, all right, be careful with your choices because you might get cross-eyed or excited that you've solved it. You have 7.5 liters first here, and you forgot to look at the name. This is chemical B, but it belongs to chemical A. So just be aware, this is not the answer, clearly, because it says 7.5 liters of chemical A. So this is it. There it is, letter C. All right. So 7.5 liters of chemical A, 2.5 liters of chemical B. And of course, adding both of them, 7.5 plus 2.5 will give you a total of 10 liters. In fact, the choices, all of them give you a total of 10 liters if you look at it properly. All right. So for the second item, it's C. Next. Now, mixture problems can be applied not only for solutions percentages, it can also be used for examples like these. Say we are dealing with grams and prices of those items. So it's just another application of mixture problem because it has the same concept. So for this problem, it is asking how many grams of 2.80 pesos per gram coffee must be added to 4.80 pesos per gram of coffee to make 50 grams of 3.48 pesos per gram of coffee. So what's different here is that all of the items are the same. They're all coffees. So here are your choices, and let's proceed. Just follow me. Of course, we have to make the diagram for this first. So for my first given, I have 2.80 pesos per gram of coffee. I'll call it X grams. And added to 4.8 pesos per grams of coffee, which is Y grams. Of course, I can name it the same variable because they are different priced coffees. It's like different solution percentages. Then both of them are equal to the final, which is 3.48 pesos per gram of coffee, 50 grams in total. So same as the previous problems, we set up the first equation, which is x plus y is equal to 50. Their weights, in this time it's weights, not volume. Then solving for x in terms of y, we'll keep that there. And the next equation, we just multiply the prices to the grams. So 2.8 pesos times x grams, 4.8 pesos per gram times y gram, and 3.48 pesos per gram times 50 grams. It makes sense because if you multiply this pesos per gram to the gram, it will get cancelled out. Grams will get cancelled out. So simple algebra, we set it up like this, and substituting y to this equation, we get this equation. Bringing out my calculator again to solve. So we have 2.8 times 4.8 times 50 minus x, keeping in mind the number of parentheses is equal to 174. Shift solve. There we go. So the answer that we got for 2.8 pesos per gram coffee is 33 grams. Going back to the choices, we can see that the correct answer here is 33 grams. All right, so we have 3 problems tonight. I hope you got the gist of how to approach mixture problems. I will be dealing with additional mixture problems in the next episodes, no problem about that. So yeah, we just finished 3 items. Thank you, and I will see you guys next time.